guys, welcome to Mariam with Math, and today we're going to be discussing the topic of differentiation, aka derivation from the syllabus Igcse Mathematics 0502. Let's get started. So, what is derivation basically? So, if I draw a function, let's say any function, I'm just gonna say this is y is equals to x square, let's say plus 2, or this could be also written as fx is equals to x square plus 2. Now, if I need to find the gradient of this function at a particular point, let's say at x equals to 1, if I need to find the gradient of this function at x is equals to 1, what would students generally do? If they have a graphical representation of this function, they would draw a tangent at x is equals to 1, a better tangent than I did. So they would draw a tangent and then they'll take 2 points on this tangent, let's say x1, y1, another point, let's say x2, y2, and then they'll find the slope or the gradient using the formula y2 minus y1 over x2 minus x1. That would give us a value of the slope. Let's say we would, for example, get 1.5. Now, everybody in the classroom would get a different answer because this is an estimated gradient. It relies on the accuracy of the tangent that we've drawn. So it won't be a fixed answer for everyone, and it will be an estimated answer. Now, that is where derivatives come in handy. We'll learn to derive this function, and once we've derived it, we'll be able to get one fixed value of the slope at x is equals to 1, or at x is equals to minus 1, or at x is equals to 0.5, or at x is equals to minus 0.5. Basically, you'll get a function, and from that function, you'll be able to find the gradient of this function at any point you need. So let's see how we'll do that. So you'll first need to derive this function. So if it's given in the form of y, you'll write dy over dx to derive it. Or if you're given the function in terms of fx, then derivative form of that is represented like this, f prime x. Both will have the same derivative. We'll learn how to find the derivative. So for this, it's going to be 2x or 2x, depending on which representation you're using. So the derivative will be 2x. And now to find the slope at x is equals to 1, or to find the gradient at x is equals to 1, all you'll need to do is multiply 2 with 1. Substitute 1 in place of x and you'll get 2. And the entire class will get the same answer, and this is the exact slope of this curve at the point x is equals to 1. If I need the slope at x equals to minus 1, I'll get minus 2. If I need the slope at x equals to 0.5, I'll get 1. So at any point you need to find the gradient, you would derivate the function, and then you'll input that value of x. So basically what derivative is doing, that let's say this is the process of derivation. If you give it an input x, it will give you the slope of that function at that particular value of x. All right, that's the basic explanation of the topic derivative. Another thing we need to know before we move on is that you might be asked to find equation of this tangent at, let's say, x is equals to 1. So then what you'll do, you'll already have an m. You'll already have this m from the process we just discussed, and then you use the formula y equals mx plus c to get the equation of this tangent. And then you'll use the concept of coordinate geometry to get c. You already have m, y is equals to 2x plus c. To find the value of c, you'll need a point on the curve x is 1. And at this corresponding point, what is y? So when x is 1, 1 square plus 2 will be 3. So at 1 comma 3, you'll use 1 comma 3 to find this c. So let's do it here. So 3 equals 2 times 1 plus c. So 1 equals c. So the equation of the tangent would be y equals 2x plus 1. This will be the equation of tangent. So you might be asked to find the slope only. You might be asked to find the equation of the tangent. Okay. Next, what you need to know is that if you're asked to find the turning point of this function, if you're asked to find the coordinates of the turning point of this function, what that means is that you're being asked to give the coordinates of this point. Now, if you draw a tangent at this point, notice that it's just a flat horizontal line, meaning that the slope at this point is 0. So slope is 0, gradient is 0. If gradient is 0, that means dy over dx equals to 0. So what you'll do, you'll write 2x is equals to 0. Again, we learn how to change this into 2x. How does derivative of x square plus 2 equals to 2x? We'll learn that shortly. Anyway, you equate it to 0, then you get x is equals to 0. So that's the value of x here. Now what's the corresponding value of y here? You simply substitute x is equals to 0 here, which gives you 0 square plus 2. So y equals 2. So the coordinates of turning point are 0, 2. This is also called turning point or stationary point, and sometimes it's also called minimum point, since it's the lowest point of the graph. So the exam question could say find the coordinates of turning point, find the coordinates of stationary point, or find the coordinates of the minimum point. That would all mean that find the derivative, equate it to 0, and then find x. From that x, find y. All right. Another thing you might be asked to find is, once you find the turning point, you'll be asked to find the nature of the turning point. So of course you won't have a graph given in any of the question. You'll be working without a graph. I drew the graph just to explain the concept behind this topic. So anyway, you'll be asked to find the turning point, and then you'll be asked to state whether the turning point is a maximum point or whether is it a minimum point. So we just learned how to find the turning point. To find the turning point, you derivate the function, then you equate it to 0. That gives you a value of x. From that x, you put that value in the original function. That gives you a y. That's how you get a turning point. Now you're not given the graph of the function, and it's a scary looking function. You don't know what the graph looks like. So this question is basically asking whether the turning point is a minimum, like in this case, or whether it's a maximum. You won't have a graph to help you figure out whether it's a maximum or a minimum. Now what you do in this case is that you derive the function again. You already have dy over dx is equals to some value. Now you derive it again. That is represented like this. You derive it again, and then let's say you get, after deriving it again, let's say you get 2x minus 1. So now you input that value of x you got from here, like you got, let's say x is equals to 3. So you'll substitute 3 over here. We're getting 2 times 3, 6, 6 minus 1, 5. So if you get a positive value, that means it's a minimum. And if you get a negative value here, let's say you got minus 5, then that means it's a maximum. Anyway, we'll talk more about this shortly when we do questions on each of these respective topics. All right, let's start with the questions now. Okay. So Here's the first question. Derivate this. Now we have to learn how to derivate it. So just to derivate, all you have to do is write dy over dx over here equals to, let me write the general formula over here. So if y equals xn, then derivative of y is equals to n x power n minus 1. So let's apply that concept over here. X power 4, 4 will come down. There's already 1 over here. So 4 will get multiplied with the coefficient of x power 4. So 1 times 4 is just 4x. And then the power gets reduced by 1. So the original power was 4. Now it's going to become 3. Plus 2 and 3 are going to get multiplied. We get 6x. Power will get reduced by 1, so 2. And then half and minus 2 will get multiplied. That gives us a minus 1. X power will get reduced by 1, so minus 2 minus 1 is minus 3. Then 3 will get multiplied with the power of x. If there's no power of x, that means it's 1. So 3 times 1 is 3. And the power of x gets reduced by 1, so the original power is 1, it gets reduced by 1, it becomes a 0. Now anything power 0 is just 1, so no need to write x power 0, so the derivative of 3x is just 3, and then we derivate minus 8. So here right now the power of x is 0, since 8 times 1 is equals to 8 times x power 0. So now you multiply these two, that gives us 0. So minus 0 times x power gets reduced by minus 1. Again, anything multiplied with a 0 is a 0, so no need to write any of this. So the answer ends at plus 3 because the derivative of minus 8 is just 0. No need to mention that. So from now on, I expect you to remember that derivative of x term is just the coefficient of x. So the derivative of 3x is just 3. And derivative of a constant term is just 0. Alright, so this is the derivative of this function y. Let's do another one. Okay, so first thing we need to do is expand the brackets. So fx equals, let's expand the brackets, 6x squared plus 9x minus 10x minus 15. Now let's simplify this further. Fx equals 6x squared minus x minus 15. Now let's derivate this. The symbol of derivation in this case is f prime x, and 6 times 2 is 12. X gets the power 2 gets reduced by 1, so it's just 1, minus the derivative of x is just 1, like we discussed earlier. It's just the coefficient of x, which is minus 1, and the derivative of a constant value is simply 0. So you end your derivation here. The derivation is 12x minus 1. The derived function is 12x minus 1. Okay, moving on. Now we'll need to derive this function. So for that, let's just simplify this. 6x cubed upon x5 plus 2x upon x5. Okay. So now if I simplify this further, I'm getting y equals 6x. X cubed divided by x5 becomes x minus 2, because we know this property of indices that if we have a power, or let's say x power a over here and x power b over here, then simplified it becomes x power a minus b. So 3 minus 5 is actually minus 2, plus 2 x power 1, and then there's x power 5 in the denominator, so 1 minus 5 is 4, so 2x power 4. Okay, so this is the simplified minus. 1 minus 5 is minus 4. So this is the simplified function. Y is equals to 6x power minus 2 plus 2x power minus 4. Now I'll derivate it. So dy over dx equals 6 and minus 2 get multiplied. So minus 12x. The power gets reduced by 1. So minus 2 minus 1 is minus 3. Then 2 and minus 4 get multiplied. So that's a minus 8x. The power gets reduced by 1, so minus 4 minus 1 is minus 5. Next question. Okay, now this is slightly different. Find the gradient of this curve. Y is equals to 3x power 4 plus 6x cubed minus 3x squared at x is equals to minus 1. All right, so what you do, you derive this function first. Dy over dx equals to 4 times 3, 12, x cubed plus 6 times 3, 18, x squared minus 3 times 2, 6x. This is the derived function. Now we need to find the value of gradient when x is equals to minus 1. So all you need to do is substitute minus 1 in this function. 12 minus 1 whole cube plus 18 times minus 1 whole square minus 6 times minus 1. So if I enter this in my calculator, that is minus 12 plus 18 plus 6. Am I right? Yeah, minus 12 plus 18 plus 6. So the gradient is 12. Okay. What other kind of questions you could see in the past papers? This is one of them. Find the coordinates of the point at which the curve with this equation has gradient 12. Alright, so gradient 12 means dy over dx is already given to you. So dy over dx is 12. Now let's derivate this function. So 3 and 2 will get multiplied. We would get 6x square plus 3 and 2 will get multiplied. We'll get 6x equated to 12. So 6x square plus 6x minus 12 equals 0. Now I'll divide both sides with 6 to simplify this function. So x square plus x minus 2 is equals to 0. Now I'll have to solve this quadratic equation. How can I do that? I think, yeah, middle term breaking should work. Multiplication should give me minus 2. Addition of the same numbers should give me 1. So that could be 2 times minus 1 and 2 minus 1 gives 1. Yeah, so I found the factors. So x square, split the middle term into plus 2x minus x minus 2 is equals to 0. X is common in the first two, so x plus 2 minus 1 is common in the next two, x plus 2 equals 0. So I'm getting x minus 1 and x plus 2. So equals to 0. So a value of x is coming out to be 1 and the other value of x is coming out to be minus 2. X equals 1 or x equals minus 2. Now the question is clearly asking for the coordinates. That means it needs the value of y as well. So to find the value of y, you just substitute this x and this x in the original equation, and that's how you'll get the y's. So y is equals to 2 times 1 cube plus 3 times 1 square. So that is just 5 in this case. And here it's y is equals to 2 times minus 2 cube plus 3 times minus 2 square. What does that get us? 2 times minus 2 whole cube plus 3 times minus 2 whole square. That gives us minus 4. So the answers are the two coordinates of the stationary points are 1, 5 and -2, -4. So in some of the graphs or in some of the curves, there are two stationary points. The curve would probably look something like this. So there's one stationary point here and another stationary point here. And in some curves, there's just one stationary point. Anyway, moving on to the next type of question you'll encounter in the exam. Okay. Please disregard what I said. It wasn't related to this. Let me clarify. There might be a curve where you will have the same slope at 2 points. For example, we could have a 12 over here. This slope is 12 and a parallel slope 12 over here. So sometimes a curve is such that at 2 points it will have the same gradient. Hence, where we get two coordinates which has the gradient 12. Okay, moving on. Find the equation of the tangent to this graph at x equals to 5. Give your answer in the form of y is equals to mx plus c. So we start with finding m. M is actually the derivative. So dy over dx equals 3 comes down, gets multiplied with 1. So 3x cube becomes 2 because we reduce the power by 1. And then minus 4 and 2 gets multiplied, minus 8x power 1 plus, when it's 4x, then we've already discussed that the derivative is just 4, the coefficient of x term. So that's the derivative. Now we have to find the slope at x is equals to 4. So I'll write m is equals to 3, replace x with 4. Okay, so I'm going to enter this in my calculator. 4 plus 4, I'm getting 20. So the slope or the gradient is 20. So the equation of the tangent is y is equals to 20x plus c. So basically what they're asking for, it's a cubic curve. So it would look something like this. Let's say x equals to 4 is here. So they're asking you to find the equation of this tangent. So you've already found the slope for this tangent that came out to be 20. Now x is 4 over here. This x is 4. You can find the value of y over here by substituting x is equals to 4 in the original equation. So that's what I'm going to do now. So I know that x is 4, however, I don't know the value of y. So for that, I'm going to substitute 4 in the original equation. So it's y equals 4 cube minus 4 times 4 square plus 4 times 4. So 4 cube minus 4 times 4 square plus 4 times 4 gives 16. So y equals 16. So that means we have 16 when x is 4. So now we can find c conveniently. Instead of y, write 16 is equals to 20 times 4 plus c. This is more of coordinate geometry. 60 in minus 20 times 4 is minus 64. So c comes out to be minus 64. So the equation of the tangent is y equals 20x minus 64. So this question was parts derivative and part coordinate geometry. All right, next question. Differentiate 6 plus 4x minus x square for part A. Part B, find the coordinates of the turning points of the graph. Okay, so for part A, all we have to do is derivate this. So derivation of 6 is 0 because it's a constant. Derivative of 4x is 4 minus 2 and x, and the power 2 gets reduced by 1. So just minus 2x. For part B, it says find the coordinates of the turning point. So for the turning point, what you do, you equate the derivative to 0. Why is that? Turning point means this point of a function. So at the turning point, the slope is 0. So the derivative is 0. That's why we found the derivative in part A. In part B, we're going to equate the derivative to 0. So we get 4 is equals to 2x. So x is equals to 2. The question says coordinates. That means we also need the value of y. So put this 2 back in the original equation to get the corresponding value of y. So that's going to be y equals 6 plus 4 times 2 minus 2 square. So 6 plus 4 times 2 minus 2 square is 10. So the coordinates of the turning point are 2, 10. Okay, moving on. A curve has this equation, find the coordinates of its two stationary points. So this is what I was talking about earlier. Sometimes a curve would look like this, which will have one turning point, and like this, which would have one turning point. Sometimes a curve would look like this, which has two turning points. So this is one of those curves which has two turning points. So we start by derivating it. So we get 3x square minus 4x plus 0. Next we equate the derivative to 0. Now I need two values of x. So I could just take x common. So I'm getting 3x minus 4 equals 0. So x is equals to 0, or 3x minus 4 equals 0. So one of the coordinates is x equals to 0, the other one is x equals to 4 by 3. Now I also need the corresponding values of y. So when x is 0, y would be 0 cube minus 2 times 0 square plus 5. So that just gives a 5. So y is 5. And for 4 over 3, it's 4 over 3 cube minus 2 times 4 over 3 square plus 5. So 4 by 3 cube minus 2 times 4 by 3 square plus 5 gives 103 upon 27. 103 upon 27, or in the mixed form, if I press Shift ST, it gives me the mixed form, which is 3 whole 22 over 27. Either form is accepted by the marking scheme, by the way. So the y is 3 whole 22 over 27. So the coordinates of the turning point are 0, 5, or 4 over 3, which should also be written in mixed form if I'm writing the other one in mixed form, 1 whole 1 by 3, 3 whole 22 over 27. Okay. Next, the final thing that you need to know is how to determine whether a turning point or a stationary point that you've just found is a maximum or a minimum. You find a turning point, let's say 7, 3. Then in the next part, you're asked to determine whether the stationary point is a maximum or minimum. That is, in the original graph, is it like this 7, 3, which means it's going to be a maximum, or is it like this 7, 3, which means it's going to be a minimum? So you don't have a graph for assistance, so you need to rely on derivatives. So let's do this question. Okay, part 1, find the coordinates of stationary point. At the stationary point of a curve, we know that derivative is equals to 0. So that's how we'll start. Dy over dx equals 0. So that's 12x square minus 3 plus 0 is equals to 0. Need to find the value of x. So that's going to be 3 upon 12. So that's 1 upon 4. And when I'll take square root on both sides, I get plus minus half. So one coordinate of x is half, the other coordinate of x of the turning point is minus half. Now I'll need to find the corresponding y's. Okay, for that I'll do y is equals to 4 times half cube minus 3 times half plus 3, and also y equals 4 minus half cube minus 3 times minus half plus 3. Let's see what we get in both the cases. So 4 times 1 by 2 power cube minus 3 times 1 by 2 plus 3. That gives me 2 in the first case. So the first coordinates of the stationary points are half comma 2, and the other coordinates would be minus half comma, let's see, I'm going to change half to minus half. Okay, so that gets me a 4. Okay, so half comma 2 and minus half comma 4 are the coordinates of the stationary points. Part 2. Determine whether each of the stationary point is a maximum or minimum. Now, what do you do here is that you already have the derived function. You derived it once. This is equals to dy over dx. Now, to find whether this is a maximum point or whether it's a minimum point, what you do, you derive the function again. So I'm going to write second derivative. So 12 times 2 is 24 x, that's it. Okay, so the second derivative is 24x. Now what you do, you substitute the values of x you got. We got half and we got minus half earlier. So I'll first substitute half. When x equals half, so the second derivative is equals to 12, which is a positive value. So you write, since second derivative is positive, is greater than 0, so this turning point half comma 2 is minimum. You will have to memorize this fact. If the second derivative's value is positive, then it's going to be then the turning point is a minimum point. And if when x is equals to minus half, the second derivative is going to be 24 times minus half, which is minus 12. So now, since second derivative is bigger than less than 0, so since second derivative is less than 0, so that coordinate minus half comma 4 is maximum point. That means in the graph, this is the maximum point and this is the minimum point. Okay. Moving on. So the graph is going to look something like this. It's going to be a combined graph, so like this. So that's the maximum point and that's the minimum point. Okay, moving on. Okay, this is the last question we'll do from this topic, and then we have discussed each and everything that gets asked in the exam from this topic. All right, so let's see, what do we have here? A curve has this equation. Work out the coordinates of the two turning points. So let's quickly do that. It's just what we did in the last part. So I'm going to do this in fast forward motion. So 3x square plus 16x plus 5. Okay, now for the turning point or stationary point, we equate the derivative to 0. 3x square plus 16x plus 5. I'm just going to use the calculator to find the solution of this quadratic equation. In fact, yeah, let's see, 3, 3, 16, 5. So I get minus 1 over 3 or minus 5. So I'll just go ahead and do it the longer way. So multiplication should get 15, addition should give 16. So that's 15 times 1 and 15 plus 1. So these are the two factors. 0 equals 3x squared plus 15x plus x plus 5. So we can take 3x common. So x plus 5 and then plus 1 common and x plus 5, so that the factorized form is this equals to 0. So the values of x are minus 1 over 3 or minus 5. Now we need a corresponding y to find the complete turning point. So we just substitute these two values here. So I'm going to do that directly in my calculator. So for the first one, I'm getting minus 1 by 3 minus 1 by 3 whole cube plus 8 times minus 1 by 3 plus 5 times minus 1 by 3. So I got minus 118 over 27. Let me confirm whether I entered everything. 9 plus 2, this. Oh, I missed a whole square, so there's that, plus 5x. Yeah. So now the answer is minus 22 over 27. Okay. And then I'll substitute minus 5. Let's do that. That gives me 50. So the two coordinates of the stationary points are minus 1 by 3, comma minus 22 over 27, and minus 5, comma 50. Now we have to determine whether these coordinates are, which of these turning points is a maximum point or a minimum point. So again, for that, you find the second derivative of the function. So this is the first derivative. So I'll derive it again. So when I take second derivative of the same function, I get 6x plus 16. Now, when x equals minus 1 over 3, then the second derivative is positive or negative. Let's see. So 6 times minus 1 by 3 plus 16. It gives a positive value, which is greater than 0. Hence, this turning point, minus 1 over 3, comma, minus 22 over 27, is minimum. And similarly, when x is equals to minus 5, then the value of the second derivative is equals to, let's see, minus 40, which is less than 0, meaning that this turning point or this stationary point is a maximum. All right, that's it. We've basically discussed everything from this topic, and I'll see you next time with another topic. Allah Hafiz, take care.